get the marks already, right? In the e-learning. Hello, everyone is here or not?
Yes,
Yes.
Okay. That all of you already scanned. The QR code is 27 per 30. Wait, I need to open my slide. Okay, basically yesterday for our, I open, for my section, I got section 3, 6, and 9. So just imagine, just yesterday, everyone is trying to contact me. I already informed all of you to make sure in the Telegram, we already inform you. Please make sure that that is a similar look. But a lot of you just ignore. Some of you, our test 2 is start at 2 p.m. yesterday, right? But 2 p.m. he cannot manage to find his virtual hall. Okay, he said, I cannot find the question, doctor. Where is it? He opened the 03 section. I don't know what happened because last time he already tagged test 1. But how come he forgot that all our test is in the virtual section 00? And some of your friends also. That's why if you just WhatsApp me related to not very critical, so I cannot reply yesterday because a lot of your friends having problem. One of that not in the Telegram, not in the e-learning. Even section 00 also is not there. I don't know what happened, and most of them is not taking the mock. That's why all of a sudden from nowhere they just pop up and they said, oh, I don't have this, I don't have that. This because they didn't take the mock. And then they said, I don't know that it is compulsory. So who said it is not compulsory? That is the thing. So please make sure, especially for your final exam, we're not going to entertain you similar what happened for your test 1 and test 2. If you have problem, you fix by yourself. If we do anything, please make sure you follow exactly when we ask you to check your e-learning, to try and etc. Please make sure you check, not until your final exam date. For that day, if you try to contact me and they said I cannot see, I cannot that and so on, we cannot help you because a lot of students will have a problem. So that's why if you think that you don't want to have a problem later on, please make sure you follow exactly what we inform you in the Telegram group. And since yesterday, if you compare to other lecturer, like they have only one section, sometimes the maximum is 2. So in similar day, they're going to entertain only like 30 students in one section. But for me, imagine I have altogether about like 96 students, and if let's say 50% of you having problem, that's why a lot of WhatsApp, I asked you to direct call me yesterday. I hope it's not going to happen to your final exam. Please make sure you follow exactly, okay? This is, I think, several time warning already because last time for test 1, we already informed you, test 2 also. But if you just continue doing it until your final exam, I don't know what will happen. Okay, next is From these three sections, yesterday I can see that my student got full mark, two of them, but it is not from our section 03. It is from section 09, I guess. Let me open your marks yesterday. Part A. Zero three. Okay, I'm going to open quite bigger. Okay, I tunjuk yang tinggi je lah ya. If not, you're going to feel like, kenapa tunjuk ni? Okay, the highest is Eng Zizing, 67. There is huge difference from the first place 67, second is Sondos 60.50. Wait, let me share you my screen. Okay, the first one is Eng Ziying, 67. Sondos are getting 60. You can see quite huge in different. And another one is Hangzi Yu, 55. And the lowest is 23. Let me double check. The lowest is 23.5. What happened? Later on, please contact me, because if compared to others, your mark also quite hard, quite different from the second lowest. From second lowest to your marks, more than 5 marks. So please make sure you contact me and inform me what is happened exactly. And then 30, 68, 68 over 2, 30, 34. Most of you are getting lower than half. Aduh. Okay, let me show you the graph, so you can see where is basically your point. You know already your marks, right? So this is the marks you can see here. The lowest is only one student. So please make sure you contact me what happened, why you are the only one get the lowest mark. And the highest just now is one also. And then average is between 48 until 53. If you think that it is not in your part, this is not your average, please make sure after this you increase your exercise. Maybe if you have question, you can do like study group. Maybe before end of class or after end of class, you can ask me question. That will be a good, I think. What else? Overall number achieved grade K. This one is similar. Let me double check the part B. For part B, you need to submit. Okay, for this test too, still got some of student tak ingat lagi apa ni, section. You still send to the different section. It is not major student, but still minor student. Just pick my name to submit the form. So please make sure for final exam, don't just look at my name, but you need to also look at the section. You are in the section 3, please submit everything, the document in section 3 only. For the submission, PDF only, you can see it's asked for PDF only. 30 student submission. 29? Submit is 29. Okay. Let me view your submission. Some of you contact me informing that you have problem with your PDF, especially, I need to view. Okay, some of you are having problem with your PDF. Some of you forgot to write the name and the section, and then some of you are, when compiling, some part of the question is gone. I don't know what happened. Maybe you are in rushing. Okay, some of you when scan, it is not clear. So you contact me and ask me what and inform me what is happened. And again, I want to mention to all of you, those who marking is not only me. We all the lecturer will divide maybe following the question. Who going to mark question number 1? Who going to mark question number 2? And also we're going to divide half by half. Maybe I'm going to get only like 30 students. Another lecturer will get 30 script. Another lecturer will get 30 script. So I don't know whether I'm going to get the script for my student or not. So this one I already mentioned in the beginning of our class starting this semester. And then I'm not the only one who marking. So if you inform me about anything, sometimes I cannot help because the one who mark is different lecturer. Unless they ask us, okay, at a specific answer scheme, okay, who is this student, who is the lecturer for this student, okay, what happened and so on, then I can come out with something. Okay. So please make sure for your final exam you prepare. Maybe you prepare the what paper, a blank paper, but you write your name first before your final exam, and then you prepare, and then you just answer at the extra line there, and then you scan. To compare also it took times, right? Okay, I can see that all of you are submit, and someone sometimes you send very clear answer. Each of 18. Okay. So we proceed first because after this at 11:45 I'm going to move to my UTM space first. Then we're going to continue again. Okay, this is my student from UTM space. So I open 2 Google Meets. Okay, now let me continue with our module 6. What we need to learn and etc. As I mentioned, you need to start with your group project. For your group project, you're going to have the unsynchronized counter. We also are already fixed that after your module 7, there is no more your synchronized circuit, but you still need to know the theory, how the synchronized circuit and etc. For your group project, you're going to do both combinations of synchronized and unsynchronized. That's why you can start doing your synchronized first. After you finish with your module 8 and module 9, you can directly combine it all together. Okay, module 8, you're going to do your asynchronous counter, synchronized counter, up-down counter, cascade counter, design the synchronized counter, counter decoding. You have 2-bit, 3-bit, 4-bit, and B, C, D decode. So what all of this? Okay, I'm going to. There is a variety of counter, of course, based on construction, based also on the scenario, based also on the system that you want to create. Counter is type of sequence. It's a sequence of a logic circuit. Generally, you're going to have two type of counter, which is synchronized and unsynchronized. Kenapa I tak boleh conteng ni? Okay, synchronized and unsynchronized. So both category can be differentiated by categorized, which is clock trigger, whether it is a positive edge or negative edge. This one we already look into your module 7. Counter, which is binary or decade. Counter direction, whether it is up or down or maybe both. Similar to the example of your group project, right? For your group project, you have what? Counter of if you have leaf to count up, or maybe your leaf for count down, or maybe both. Okay. So you can see here in the previous lecture for module 7, you already look into all these flip-flop. This flip-flop can be connected together. You can combine your SR flip-flop with your JK flip-flop, let's say, or maybe your JK flip-flop, you combine together, you're going to get one system. So in this following lecture, we use this flip-flop, the one that we have learned, to construct a variety of counters. In addition, we will also learn the method for analyzing the different type of counter. Okay, I teringat sikit what has happened is, last time I asked section 9 student, I mentioned to them, they are very quiet. Okay, in the WhatsApp group, sometimes they didn't say anything. In class also, there is really quiet. They didn't have anything like complaint, or maybe they didn't, I don't know what happened, but most of them getting high marks. I don't know, but they always do the exercise, and then after that they will like contact me after the class. They like to do like one by one. Normally in like when there is a lot of students together, they will just quiet. I don't know what happened. But maybe that is the style. They like to like ask a question without their friend knowing. I don't know. So this is a recap on your sequential circuit, what you have been through together. General sequence circuit that consists of combination logic sections and the memory section, which is your flip-flop. This is your sequential circuit when you have the memory of your previous output. So you have the clock signal to trigger your output, isn't it? And okay. So if you want to create a counter, what is counter? Before you can create it, you need to know what is a counter. A counter, any sequential circuit that goes through a prescribed sequence of stage upon the applications of input pulse. So this is example. The sequence of state in a counter may follow a binary count. So you can see, or other sequence. So this is binary count. You can see you have 0, 0, 1, and then after that 0, 0, 0, 0, 0, and then 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and until you continue. You can also have like 1, 1, 1, and etc. But it is depend on your count up. Maybe for this problem, you are counting up from 0 to 6. After 6, you going to continue back to 0, 1, 2, 3, 4, 5, 6. Wait, it is not following the sequence. From 0, 1, here is 3, here is 2, and this one is 6, 7, 5, 4. So it's not following the continuous. It's not continuous, but you can see there is a counting. From 0, maybe it's count to 1. After 1, it's going to count of 3, depending on scenario. Later on, you will see how come it's going to be like this. Okay, so you can also have the state can change by the input pulse. It's depend on your input pulse. That's why you get the next output. It's depend on your input pulse. That's why you get those output. The input pulse count pulse may be a clock pulse or maybe also original from the extra source. So counter are generally made up of flip-flop combined with your logic circuit, logic gate. Sometimes you can just use flip-flop. Sometimes you need also a logic circuit, but normally it's going to be a combination of your flip-flop and also your logic gate. Can return an output state after the input condition. So classified as sequential circuit. Can have more than 2 states. You can go to this one, but sometimes you can go back to specific state. So depend on your trigger for the clock. Value of state is expressed as a multi-digit. You can choose whether it's 1 or 0. And the state of number limited only amount of electronic. Okay, you can read it and understand. So mainly it's going to use KK flip-flop. But you can also have the T and also D flip-flop. Use of counter to count the number of times that certain event takes place. To be counted is represented by the input. Okay, so this is the scenario given. And you are given here the example of counter for parking space. How many parking space that available? So let's say at the level 1, it's count already 90. Level 4, this. So this is the example how you can conduct your circuit. You have here entrance sensor as the input for the up. And then exit count sensor is going to be a down, counting down, isn't it? So this is your counter and there is a clock. You're going to compare maximum number of space. Let's say you have at each level 500. Then you compare how many times. Let's say for the beginning, when you start the parking. Okay, this is parking. This is gate. In and then out. Let's say if you count 1 going in, So you're going to compare with 500, right? So the space, we look only level 1, let's say. Level 1. For this part, for level 1, now when there is one car coming in, it's going to be count up. It's going to come up, and this counter will compare with the space there, which is 500. And now it's going to whether it is full or not. And it's going to pop up. There is a display connection here. Now it will be 499. And then there is 2 car coming in. It's still going up. And then it's going to compare whether it's full or not, or maybe it's going to display the value 498. Suddenly 1 car go out. So it's going to exit sensor, it's going to count down. Countdown is going to compare with the existing one. You're going to have 499, let's say. You're going to compare with this. But this is depend on your value. First, counting up, you have 1. This one, you compare with this 500 minus 1. This one is counting down. Now you have 1. It's counting down. It's going to minus 1, you get 0. 0, you compare with your maximum number, you have 500. So this is the scenario. As I mentioned, you need to think how your scenario will be look like. Maybe you said there is 2 entrants. The scenario, as I mentioned, the scenario is depend on you for the project. But if let's say for the test, for your final exam, the scenario will be given. You need to follow exactly what is scenario, and then you come up with your circuit. But for your project, the scenario is you are the one who set. Maybe you want to have 3 entrants, level 1, level 2, level 3. And your exit, maybe you're going to have 3 exit, or maybe you want to have 1 exit only. So it's all depend on your own scenario, okay? This example here, to control fixed sequence action of a gate must be open. Gate A must be open before gate B. Okay, so let's say for this one, you have 2 gates. Gate A, and then, sorry that I don't know how to draw a gate. This one gate A, this one is gate B. Maybe say gate A must be open before B. So when you want to come inside, okay, this is your house. Okay, this is your house. Of course, you need to move and meet the gate A first. Gate A must be open before gate B. Okay, so when you going here, okay, A will be open. Then after that, you're going to say, okay, maybe 50 seconds later, it's going to open your gate B. Or it's depend on you how you're going to trigger. Okay, so next, there is example here for the bomb generate timing signal. So it's depend on you. When you pull the trigger here, it's going to count like 20 seconds, and then after a button is pressed. Okay, this one is button press. Sometimes you can also pull, and then after that, it's going to bomb. Another example to generate clock on different frequency. There are many devices used that can tell the time without having the manual program. So by dividing frequency, we can get different clock frequency from the same source. Okay, later on, we continue to the next slide. Wait, I mute this class first, okay? I need to go for my space. They're going to have a test at 12 PM. So I just want to open the test and then I go back here. Okay, wait.
So when we pass the question, can we come back to the previous?
Oh, wait. Hi, okay, sorry, I just give my UTM space student with your test. So we're going to continue. Okay, we continue with our characters of counter. Counter can be described by the following characters.
Doctor, you are in UTM space, Doctor.
I tak mute lagi Sorry. Okay. Okay, now you can see here, counter can be described by the following character. First, whether the counter is asynchronized or synchronized. If synchronized, you just follow exactly for your flip-flop. Last time, it's JK, you look into this JK, SR, you look at this SR. But asynchronized is going to depend also on your pre and your clear, if you still remember. And next is counting sequence, whether it's up or down, or up, down, or a random. It depends on the scenario. Third is modulus. What is modulus? Modulus is very important also because it's going to be asked in your final exam a lot of, especially for your part A, also including for your part B. And another one is whether the counter repeat or not, or maybe if let's say from 0 it's going to count until 5 and then it stops. But if it is repeat, means that it's going to go back to the previous value. Next, you have here counter character. You can say you have unsynchronized and synchronized, whether the clock came from the same source or not. This one you already look. Last time we have like this. Let's say you have the JK flip-flop here. JK, JK, JK. this is your input, this is your input, of course, this is your input, and of course, you're going to have the clock. You have a clock. And this clock, is it from the same clock? The same clock. This one is, of course, your Q. Maybe this one is Q0, Q1, Q2. It depends on how many digits you have. And if it is one similar source, you can see here, same source. So it's look like this. But if it's not, okay, this is also a clock. It's going to be like this. Your Q bar will be your next clock. Your Q bar here will be your next clock. So synchronize, all clock is same source. The one that I draw just now, like this, right? So this is all the same source. Source is called as synchronized. But if it is unsynchronized, it's going to be look like this, which is clock for each flip-flop come from different source. And normally we're going to have like this one. Q bar will be your next clock. Q bar will be next clock. But this one will be normally for your counter. How it's going to be look for your counting up? It's going to be connected to your Q bar. How about if let's say it's called clock down? So here we're going to look into the example letter. Okay, this is unsynchronized clock. You can see here the clock are similar source. Same source called as synchronized. For unsynchronized, so you can see either this one is your Q. Your Q is the next clock. Your Q is the next clock. This one, and if let's say it is bar will be your next clock, what happened? Is this counting down or this one is counting down? Is this counting up or this one is counting up? So later we will look into the specific how about the counting up and counting down. But first of all, you need to know synchronized, same source, unsynchronized, different source. Okay. In terms of connection, later you're going to be given the table how it's going to be look. So second, counting sequence, up, down, or maybe both. You have both. So up or down is called as unidirection. Uni normally one, whether up or whether it's down. So only one you have. The count sequence only one way. If you have by you know it's going to be up and down. So you need to have both. So this is example of uni. This is example of uni because you can see here one way only. One way only. But for this third example here, you can see you have this way and you have the vice versa way, similar to this part here and here. You have two way we call as bi-direction. Because of limited word length, the count sequence is limited. So you're going to have from the minimum of 0 until to the power of n1. What? Minus 1. What meaning by this? For a n-bit counter, if let's say you can see you have from kita mulakan dengan 1. If let's say you want to have 1 bits, of course you have 0 and 1. You can go to here. This one will be go to this. 1 bit, you have 0 and then to the power of 1 minus 1. What it is? 0 until 2 the power of 1 is 2 and you have 1. So you're going to have only 0 to 1. But if you have 2 bit, 2 bit is going to have 0, 0, 0, 1, 1, 0, 1, 1, right? And you're going to have 0 until to the power of 2 minus 1. 0, and then you have until 3 times. 0, 1, 2, 3. Okay? Similar to if you have 3 bits, 4 bits, 5 bits, and etc. So here is our 2 bits. You can see this is 2 bit, 2 bit. We have 0, 1, 2, 3. Or back. 0, 1, 2, 3. So when counting up, the counter will be 0, 1, 2, 3, 4, 5, 6, 7 until to the power of n minus 1. Okay, when counting down, it's vice versa, of course. It's going to start with your 2 the power of n minus 1. This is the maximum until your minimum will be 0. Okay, you can see you need to check the character of whether it is synchronized or unsynchronized. Second is counting sequence. And now you're going to look into modulus. What is modulus? Modulus, or we call as mode, the number of state that counter can have. Example, when you have mode 4, means that you have 4 states, which following 0, 1, 2, 3. Maksudnya you have from like 0, 0, 0, 1, 0, 2. Let's say you have like this. This is 3 state. If you have 4, you're going to have 0, 3. You have 4 state. If you have mode 9, you're going to have 0, 0, 0, 1, 0, 2, let's say 0, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All together, you have 1 state, 2 state, 3 state, 4 state, 5 state, 6 state, 7 state, 8 state, 9 state. That's why it's called as mode 9. Okay, that is about mode. Mode is depending on your state. This one, mode what? This is 4. 1, 2, 3, 4. 4 mode. This is also 4 mode. This is also 4 mode. Okay. The maximum count usually to the power of n minus 1, where n is the numbers of flip-flop. Okay, you need to have a flip-flop, or for the transcaded sequence of maximum count, blah, blah, blah. Okay. This one, another things that you need to consider when you want to create your counter, repeat counting sequence. Whether the counter repeat the counting sequence or not. If it repeat, we call as recycle. If the counter goes back to the first count after maximum, then you have 0, 0, 0, 1, 1, 0, 1, 1. If you continues, this is the maximum if you continues to be at your state 1. So it's meant as recycle. While for saturate, it's going to be the counter repeat the maximum count if count up, or repeat the minimum if counter down. Okay, so you can see if it's going to be counter up, let's say it's counter up, right? So it's going to repeat for the maximum count. So it's going to be repeat here. For if it is counting down, it's going to go to the minimum. This is the minimum. So if you have like counting up, it's going to be starting at the maximum. So that is under recycle and saturate. Now you have here the unsynchronized counters. Asynchronous counter and AC is one in which flip-flop within. Okay, you can read it. I don't like to read. The clock SC here, it always connected to your LSB flip-flop. And so that's why it starts with your Q0. What is your LSB? Okay, let me give you example of number 197. Here will be your LSB start. Here will be your MSB. And you already learned LSB and MSB at your numbering system. Okay, at your numbering system, you already learned LSB and MSB. Okay, you can see here at this example, your first clock, you can see here, your first clock are connected to your flip-flop of your LSB. That's why your output is Q0, J0, which is if you have the number of Q, right, you are having this kind of looks. This is your MSB. This is your LSB. So this is like flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3, and etc. So please remember that for your unsynchronized counter, you're going to have the first clock going to connect to your LSB flip-flop. And your SC known as a ripple counter, which is message signal passing or propagation delay, your AC, which is your unsynchronized counter. It also known as macam dia punya nickname. Another nickname for unsynchronized counter is ripple counter. Normally, this kind of question will be asked in your part A, which is the theory. What is unsynchronized? Unsynchronized also known as ripple clock. That is very simple, direct question. So comparison with synchronized and unsynchronized. Just now, also we already looked into. Unsynchronized is going to be...
Sebab pasal clock Mio.
Apa dia? Is it question or what? Hello.
No, that's it. I just doing my project. Serious.
Sambil tu you boleh pula berdiscuss. Okay. Comparison of unsynchronized and synchronized. You can see here, you have unsynchronized and synchronized. Unsynchronized, you have different clock. And synchronized, you have similar clock. But in terms of connection, this one is depend on whether it's counting up, counting down. After this, we're going to look. So this is the comparison, synchronized and unsynchronized. How you're going to differentiate it directly. Unsynchronized counter operation, if positive age, this one also you know already, look at your clock. At your clock here, you know, okay, this is positive age. If you have that bubble there, you're going to have negative age. Okay, unsynchronized counter is slow because the cascade clocking scheme. Kenapa? It's directly because you need to wait this output first, then this flip-flop can get another output. After this Q is getting out, it's going to trigger to next flip-flop. But you can see if you have directly from one clock, you're going to on and do it parallelly. That's why it's much more faster if you compare to your unsynchronized, which is connect to different clock. The ripple effect is similar to the ripple carry adder circuit. This is a table that I mentioned just now. How the looks. If you have positive edge, you're going to have positive clock there. Okay, this is the first thing that you need to look into. Positive edge, you need to have the positive clock. Similar to another example there. Next, what happened is the input for J and K is similar, okay? Whether it is counting up or counting down, both are connecting to the high. You can see here, J, K are connected to the high. For positive edge, negative edge also, we're going to connect to the high. All is connected to the high. The difference only at this clock, positive, negative, you know the comparison. And after that, another difference is whether it is counting up or counting down. For counting up, positive edge, you're going to connect your next clock to your Q bar, your previous Q bar. If you have negative edge, you're going to have connection to your next clocks to your Q. So you need to remember. If you have positive edge, you want to counting down, you're going to connect to your Q, previous Q, to your next clock. While for your negative edge, if you want to count down, you're going to connect to your Q bar, previous Q bar, to your next negative clock. So all this connection, you need to remember for what? All this connection here. So if you were given with the question, okay, draw mode 4 counting counter, let's say. So counting up. It's already mentioned counting up. So you need to know, okay, counting up is here. So it said positive edge. So you know it is look like this and it's mentioned mode 4. So you should have 4 flip-flop. Mode 4, positive edge, and counting up. So you're going to connect the connection of J and K, I already mentioned, is going to be high, similar to all. Okay, and our clock here, first we're going to connect to clock, and this will be positive, this will be positive, oh sorry, it will be positive, 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 and the connection will be at our Q bar, so it will be like this. Then you have mark already. This one is your Q0, Q1, Q2, Q3. This is your Q3 bar, Q2 bar, Q1 bar, Q0 bar. Or maybe if it's flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3. This is if the question asks you, okay, please draw the counting up for mode 4, positive edge counting up. It can be also said to you 3 mode. 3 mode, you just remove another one. and maybe negative clock, you put negative, and then counting down is here, negative is similar connection. So the first thing that you need to know is you need to remember all the connection in terms of negative edge, positive edge, counting up, counting down. Once you know the basic connection here, the rest, whether it is mode 9, it is mode 11, it is mode 100, you can directly draw because the rest connection is similar. Okay, so the summarization, the circuit connection almost the same, where external clock connected to the LSB. This is your LSB, the smallest I mentioned already. So clock for each flip-flop came from the previous flip-flop. Except for the first one. First one, this is your first flip-flop. You're going to connect to the existing flip-flop clock only. Okay, so you can read for another toggle the flip-flop, what is happened. Another one is on the design connection is similar, although it is T, although it is D, as long as you know and understand the correlation between your JK flip-flop and others flip-flop. Okay, let's say here we have example. We're going to have count up 2-bit unsynchronized clock. So 2-bit, you know, is going to have 2 flip-flop because you have you're going to have 2 mode. So you're going to count up. You have 0, 0, 0, 1, 1, 0, 1, 1 for 2-bit, isn't it? So normally you're going to have like Q0, Q1. For the input, it's going to be like J0, J1, K1, K0, something like that for the 2-bit. So you're going to see for the first question here, it is positive edge. Okay, then is a positive edge. Positive edge. The rest of connection, I inform you that it is similar. It is similar connection. And then how about assume the initial Q0 is low. Okay, this one is in terms of connection here. Assume the Q0 is low. Q0 initial is low. Okay, this is the low. And what is the output? And the connection is look like this for your counting up. Refer back to your table here. For counting up, this is look like this. So how you're going to determine your output? Let me do one by one. First, what you need to do, the dotted line. Where you're going to draw your dotted line? You're going to draw your dotted line at the active or positive clock edge. Positive, 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 draw the dotted. Okay, I already done drawing my dotted line here. And after that, you can see here what has happened. Look back at your JK flip-flop. If you have input 1, 1, what is your Q? Is it toggle? I also already forgot. I think it is toggle. For JK, if you look back, JK, you have 0, 0, 0, 1, 1, 0, which is supposedly it's going to similar to your SR. SR will be no change. It will be reset and set. This one for SR is going to be invalid, but for JK it's going to be toggle. Okay, so remember back your normal flip-flop. Okay, when you're going to trigger your output, when you have a positive clock, positive clock, positive clock, positive clock. So starting is, alamak warna tak nampak. Okay, starting at initial low. Don't look at these two. You're going to be confused because now you are trying to fix this one first. Okay. So when you meet here for your positive clock, you're going to trigger and look into your input. JK input is 1. JK input is 1. Isn't it? Because it fixed the value. Look into your JK flip-flop is 1 and 1 is going to be toggle. Toggle to 1. From 0 it's going to be 1. It's going to continue until you meet another positive clock. At this positive clock, you're going to look into your JK value. Your JK value is what? 1, 1. It's going to be toggle. So you're going to toggle until you meet another next positive clock. Now it is a positive clock. It's going to be toggle again from 0 to 1. Continue until a next positive clock. You stop. You refer to your input value. Your input value is what? 1, 1. It's going to be toggle from 1 to 0. Continue until you meet another next positive input and you check and refer your JK value. And then you're going to do whatever value of JK. If JK is 0, 1, J is 0, K is 1, what happened? It's going to be reset. So it's going to be continuous. If it is 1, 0, it's going to be set. If it is 0, 0, it's no change. Okay? So please make sure you remember that. We have learned it in module 7. Now, after we done with our first flip-flop here, we already done, okay? Now, this output we already get. Q0, this is our Q0. We done already. We already get Q0. Similar to our Q bar, we already got done also. That's why we will toggle everything our Q bar. Okay. Go to the next. You can see here, this is a positive, but our clock here will be on our Q bar. So this will be another clock. Another, maybe you can assume this is clock 0, this is clock 1, which is similar also for your Q0 bar. And because this is a positive edge, you're going to look into the positive edge only. Here is positive edge. I ask you to draw the dotted line for the positive edge. Sorry, this is not positive edge. This is your another positive edge. For this side and this side only. Starting is going to be a 0. But for your Q, of course, starting there is nothing happen until you meet to your positive edge. Positive edge here, you look into your JK value, it is 1, 1, you're going to be toggle. Continue until you meet another positive edge here. It's going to be toggle again until you meet another positive clock. Going to be toggle, toggle, and toggle. So what happened here? The conclusion is you can see this output will be generated depending on this clock. What is your clock? Your clock is Q0 bar. Now will be your next clock like this. 1, 2, 3. So this is totally your similar clock like this one, right? But this is from your Q bar value. It is now your CLK1. Okay, let's see another example. So this is the value of your Q. You can see here you will put 1, 0, 1, 0. Here will be 0, 1, 0, 1. So you can put the value in 1, 0, 1, 0, 1, 0, 1, 0, and for your Q1 0, 1, 1, 0, 0, 1, 1, 0 at the initial clock. 1, 2, 3, 4. Because sometimes the question will be asked, okay, at the clock 3, what is the output? So you know your output will be 1, 1 for the clock 3 and etc. Okay, you can read and go through. This one is totally similar what I explained just now. Okay, you've been asked a 2-bit similar using JK similar. Now it is negative H. Okay, just now it is a positive H. Remember back, first thing you were given with a value of 2 bits. Okay, I draw my JK. And I'm going to connect my JK there. Okay, high. What else? I need to have clock. Now it's negative. I draw a negative clock there. Initially, my FF0, FF1, initially it's going to meet my initial clock. And I have the Q0 and this one is Q1. Here will be my J0, K0, J1, K1. Draw the connection. So I try to draw now. And for the negative H, counting up. Just now is counting up, negative. Okay, it's going to be look like this. This will be connect to your next. So this is my Q0 bar. Q1 bar. So this is the connection that will be happen. So it asks you, draw the 5-wave output, 5 clock cycle. Alamak, tak muat. I delete So it's going to be totally like this. This is the one. You can see the connection. This is the only thing that I mentioned will be the different. Now it asks you for the second one is draw the waveform output 5 clock cycle. So macam mana I tak ada pembaris ni? 1, 2, 3, 4, 5. Okay, done. This is my clock. My JK value fixed to be 1 both. And I'm going to have Q0 first. What happened? I'm going to do at the negative H. Negative H, this here, this here, this here, this here, this here. 1, 2, 3, 4, 5 clock. I'm going to draw the dotted line. Draw the waveform output of 5 clock. Okay, kenapa dia tak mulakan count up, ripple, design? it didn't give the initial value we assume as a negative low, okay? So you're going to continue until low, and then what happened is going to be toggle. You can see here low and meet your negative clock, meet until negative clock, meet until your negative clock, meet until your negative clock. Okay, now you done this part. You're counting up negative edge. Your next cycle, your next clock is connecting to your Q, not your Q bar. So no need for you to draw the Q0 bar. This will be your next clock. So what happened? You're going to draw the negative. So this will be your next clock. This will be your next clock. This will be your next clock. Okay, we start with the low. Now we have Q1. Meet until my negative, I'm going to toggle. Meet until my negative, I'm going to toggle. And then, so finish already. So that is my timing state of, okay, this one is not yet. This is my wave of 5 clock cycle. Okay, you look here. This is exactly what happened. And initially, you can see it's already started low. But in the equation, I think it's didn't mention. Draw the 4 clock cycle. Why flow? Just now, why 4? Just now it's asked 5. 5 clock. But it's okay. You can see it's basically similar, right? You didn't, you're going to see like this. Negative. At this specific negative clock, you're going to toggle. Now this Q0, you can see Q0 not Q bar, okay? Q0 will be your next clock. This is negative. You continue until you meet the negative clock, toggle. Another next negative clock, toggle again. So you finish. If you have another Q2, so you're going to have until you meet your negative clock. So you toggle. So this is your answer. Okay, now you were given with this. What will happen is you need to state the value. I put the value, okay. What color I want to put? 0, 0. At this clock 2, 1, 0. At this clock 3, 0, 1, 4, 1, 1, and 5 is 0, 0, 0. I hope that I correct. Okay, starting here at clock 1, I have 0, 0. Clock 2, I have 1, 0. This is a table of state. Clock 3 is 0, 1. Clock 4 is 1, 1, and another one is 5, is clock 0, 0 back. So this one is done. Now to draw the timing diagram, you just draw 0, 0, and then 1, 0, and then 0, 1, and then 1, 1, and then you go back, right, to 0, 0. So you're going to draw like this. This is your state diagram. Okay, look much more clear. You can see here. This is the things that we just mapping. And from here, initial, this is 0, 0. And then you're going to continue to your 0, 1. And you're going to continue to 1, 0. And then 1, 1. Kenapa I punya jawapan 1, 1 here? Oh, because I have 5. Yeah, it's correct, right? 4. Okay. 1, 0. Mine is 1, 0 here. Oh, Q1 there. I see. I also did wrong. You can see here it is Q1 at this side, Q0 at this side. This now I do vice versa. Okay, so that's why I'm wrong. So you need to see it's counting up. Supposedly it's going to be follow the sequence at this side. My answer will be 0, 0, 0, 1, 1, 0, 1, 1. Okay. This one is Q1, Q0. Q1, Q0, Q1. Okay, so it's supposedly vice versa, which is B1, Q1, and then Q0. Okay. So that is the type of question that will be asked. You were given with this question, counting up or counting down, how many bits, or maybe it's directly give you modes, which is total number of your flip-flop, and then whether it is a positive edge or not, and initial value of Q will be given. You have A, B, C, D question, draw the logic, which is the flip-flop drawing. Waveform, your 5 clocks, construct a state table and timing diagram, state diagram. So you will get like this. And next, you can see similar question, but you have 3 bits. Negative edge is still similar, but now you need to draw 8 clocks. 3 bits. You're going to have 3 flip-flop here. Negative edge, similar, but now it's counting down. So that's why the counting down negative will be connecting like this. 3 bit. You done with the first. Second, you're going to draw. Let me show you what is happened. We're going to have the negative edge. Like this, like this, like this. Now you can see you need to consider your Q bar because your next clock is depending on the previous Q bar there. Okay, this is your Q here. You're going to have the initial value, you continue until your next negative clock. It's going to be toggle. No need for me to repeat why it's toggle because it is a connecting to the 1, 1. And it's continue. Where is my pen? Okay, it's continue to the next negative clock, continue next negative clock, continue next negative clock, continue next negative clock, toggle, toggle everything. Now I done here. The Q bar will be toggle from my Q. So it will be look like this. After I draw this part, this will be my next clock, clock 1. This is clock 0. This is my next clock. I'm going to draw the negative clock here. So at this stage, it's going to trigger my next output. This is my Q now. Starting at 0, it's going to be toggle. Meet the negative, I'm going to be toggle. Next to my negative clock, it's going to be toggle. It's going to be toggle. And I'm going to draw my Q bar, which is totally toggle from my Q1. Okay, done. This is another another clock. So it's going to be like this. 1, 2, 3. This will be my negative Q1, Q2 bar, Q2. This will be my Q bar, 0 bar. This is my CLK. The rest, JK is similar, JK is similar, JK is similar. It's connecting to what? To the high. So you can see you're done with your Q0, Q1. Now you're going to do the Q2 here. Negative, negative. At this specific only, it's going to be toggle. It's going to be toggle. So this is my final answer. How are you going to do it? Later on, this is question number 1. You're going to fill in the value at cycle 1. Cycle 1, the value is 0, 0, 0. This one, 1. Here, 1, 1. This one is 0, 1, 1. Number 4 here, 1, 0, 1. Number 5 here, 0, 1. Salah. 0, 0, 1. Number 6 here, 1, 0, 0. Number 7, 0, 1, 0. Number 8, 1. Saya dah salah kat sini. 1, 1. Here we have 1, 0, 0. Kat sini je, it's going to be here only Q0, Q1, Q2. And then you draw your timing diagram. Your timing diagram for your Q cycle 1, 2, 3, 4, 5, 6, 7. Q2, Q1, Q0. At this cycle, it's going to be 0, 0, 0. At this cycle, it will be 1, 1, 1. At this cycle, it will be 1, 1, 0. At this cycle, it will be 1, 0, 1. Here will be 1, 0, 0. Here will be 0, 1, 1. Here will be 0, 1, 0. And lastly, cycle number 8 will be 0, 0, 1. So how are you going to draw? You have from this to this. 0, 0, 0 is go to 1, 1, 1. And then after that is go to 1, 1, 0. After that is go to 1, 0, 1. Then it's go to 1, 0, 0. Then it's go to 0, 1, 1. After that 0, 1, 0. Then 0, 0, 1. Finish. So you can see it's going to counting down. 7, 6, 5, 4, 3, 2, 1, 0. It's continuous. And in a proper way, you can see this is the answer. Totally similar what I draw just now. Similar to the table and also the timing diagram here. You can see, okay, this is the initial part. And it's going to continue with starting at 111 and then 110 and then you continue. So that is all about this counter. Later on, you're going to see that you can jump from one state to another, from one state to another, from one state to another, depending on the trigger. Okay, but we're not going to cover here. I want you to first of all memorize the connection, how it's going to be look like. Second, what is happen when I have positive edge counting out? What is happen positive edge counting down? Try to do as many as can saya punya student yang mana pasti. Saya rasa student space dah habis. Ya. Okay, so over here you need to remember this first. Later for our next class, tomorrow, okay, we're going to continue for our next subtopic. What we're going to do for next, from 1 until 2. Oh, it's already break. Okay, after this, I hope that you can finalize your scenario. Finalize for your scenario for your group project, okay? Don't wait until last minute because after this, there is a lot of other things, assignment, lab, you need to finish. Okay, any question until here? Any question? If there is no more, if there is more no question, if there is no more question, we're going to start our class. I hope that all of you already scanned the QR code. And